conferences. So thank you everyone for coming. I'm really excited to talk to you today about data governance and AI on data governance. And just to quickly give you a little bit of an overview of myself, I've been with Accenture's big data group for 5 years. I was actually one of our first big data employees. And I started at Accenture as a Java engine rules developer. And I've worked for a few different clients doing rules engine development and really getting into governance and data management and data policies. And it was about 1.5 years ago that I was working for a really large European telco, and I was engineering a solution to share data between different countries. So engineering a solution where we were actually taking a lot of different kinds of customer data and different kinds of probe data, and we wanted to create some really good intelligence on top of it. We were having a lot of challenges effectively bringing that information across borders. And I realized that I thought there was kind of a gap in this space in the marketplace for how we can really grow big data at scale and also do governance and do management as we need to. So that's what I'll be talking with you about today. And just to kind of define data governance a little bit more, data governance, of course, is the practice of ensuring that we're meeting all of our different agreed upon standards. And data governance has a lot of overlaps with compliance and with legal entities. And some of those companies are actually, those entities are listed on the screen right here. So we can see that we have the Data Protection Act of 1998. This was actually really the first piece of litigation that sought to define what personal information is, define what private information is, and then also build out a framework for how we can share that information. Another logo up there is PCI compliance. So PCI in the payments industry is really big. The first big data PCI compliance solution came out about 1.5 years ago. So a lot of movement in this space. And recently we've been talking to a lot of healthcare clients and insurance providers that want to enhance their HIPAA compliance, and they want to be able to share medical information a lot more quickly. So at a high level, there's a lot of compliance and legal issues, but there's also a lot of benefits of a strong data governance strategy as well. And I think it's good to understand these benefits because data governance is really an investment, right? So this isn't some kind of really cool analytics or some awesome visualization or even some kind of awesome AI that's going to generate us billions of dollars. This is more of an investment long term to making sure that we can be compliant and that we can manage information at scale. So it's good to understand, I think, some of the benefits just beyond the simple compliance of staying legal. So what are some of those benefits? Well, we can't really talk about data governance without talking about security. And in this talk, in the demo that we've actually prepared, there's a lot of overlaps with security and with data governance. And using data governance frameworks to enhance our security offering, whether that be through better user management or in better data encryption frameworks. Data governance can also help us reduce data maintenance costs. I recently heard some horrible statistic that among the average big data platform, the amount of information only used on a week-to-week basis was around 7%. Which is a pretty low utilization rate. And I would guess that companies aren't just spending money for no reason to house all that information, but maybe that they don't realize they're not using it. Or maybe it's not of a quality and of an organized way that we can actually effectively use it. So we want to unlock that information. That can help us also reduce some of our operations costs. Productization of data, which isn't a word that really rolls off the tongue, which is different than production data. But this is about actually making our data into a product, and there's a lot of really great companies that have been doing that. Google was obviously one of the first big companies to productize data. Recently, GE has done some really cool things with their Predix platform. But this is how clients are actually taking all the information that they're getting from their customers and all the information they're gathering. They're developing really cool, unique analytics on it, and then they're selling that back as a product, right? So they're actually productizing their data. And in order for them to do that at scale, of course, it has to be very governed and it has to be very managed. It has to be of a very high quality. So there are a lot of other benefits to data governance beyond just simple compliance. A little bit to talk about governance in big data. Governance, like so many other technical frameworks, technical topics, sits at the intersection of people, processes, and technology. And the people of governance are our data stewards and our data owners and the people that understand the information. It could be the 25 different data scientists that we're all expected to roll on in the next month. For processes, these could be technical processes or these could be business processes. And then the technology, right? So the actual platform that we want to build and all of the different tools that we're going to look at. And there are a ton of tools in the marketplace right now in the data governance space. And before we kind of talk about what some of the challenges are in doing data governance on big data, I think it's good to kind of break down the problem a little bit further. And these blue pillars that just came up on the right, this is actually kind of an attempt at breaking down end-to-end data governance into a set of topics that we can define technical terms to, right? So I think a lot of people in this room are familiar with most of these things, so I won't spend too much time. But doing things like data profiling, so fully understanding our information. Being able to execute policies that we can write in business terms that can do actionable management. And making sure that storage and retention are being maintained. Social media data, there's a lot of laws going into place right now for how long we can hold on to people's social media data. So there's going to be a lot more rules around this. And what's kind of good about breaking it into these different topics is that we can choose what's most important to us and build a strategy. And it also allows us to break down a lot of the technologies and a lot of the tools that are in the marketplace, because there are, as I mentioned, there are many tools in the data governance space, and within this initiative alone, we've looked at over 30. And a lot of them say they can do everything. And everything wasn't the most specific term for us. We kind of wanted to break down everything into some things that we could cross-evaluate all these tools against. And this is kind of where we got. And this is the third iteration, and it's kind of always moving piece, but this was sort of our way of breaking down data governance into some major topics. So what are the challenges? Like, you know, Accenture has had a data governance group for a long time, and we have a lot of data governance artifacts. So why am I here? Well, I'm here because we thought that the new big data architecture and the new way that companies want to do digital business is creating a lot of unique challenges in the data governance space. And to kind of talk about some of these challenges at a high level, architecture paradigms are changing, right? So now we have data sources in the cloud, we have on-premise data sources, we have many different types of organizational models. So as companies acquire other companies, or as companies want to become digital data companies, they want to roll on new types of users, and there are lots of different people involved. And as there's more and more people involved, organizing all those people effectively is very different. The third one's kind of obvious, you know, more data equals more policies and rules. And of course that's true. You know, if we bring in consumer data versus billing data versus third-party data, this is all going to present, they're all going to have their unique challenges. But it's also about kind of the processes that are written into the data, because, you know, as many of us know that have tried to work on large data warehousing projects, oftentimes we're bringing in sample data sets or we're looking at reports. Those reports may have been written by someone that, you know, left the company years ago. So tracking down all of this sourcing information can be very difficult. The methodology that we're actually building these applications is changing. So, you know, it's not the 100-day golden build everyone on the phone anymore. It's more of a waterfall methodology where people want to be able to deploy code and test it very quickly. And we want to create a solution that allows us to segment our environment and allow people to move much quicker. And the last part, you know, operations and logs. So in our Hadoop stack and our big data environment, we have lots of different applications. Oftentimes those applications are all generating their own logs, generating their own operational metadata. So it can be difficult to scale and to really grow data governance in a way that matches the scalability that we see with our clients. And I think that when we do try to build out the data lake, as a lot of us have seen, there's kind of two main paths and two pitfalls of doing this. Is that if we build our data lake, we could just bring in a lot of different types of data, and you know and sort of replicate the data. So we bring in all of our different data sources, and we have it on our big data platform. And we always talk about turning off the back-end data systems, and we talk about replacing our legacy systems. But that roadmap, as a lot of us have found out, is very long. And the other option is, if you don't want to bring into the data lake and replicate it, you could do what I'm seeing some clients do now, which is create just massive API-driven infrastructure, where it's just kind of a huge middle layer, and we just decide to extract what pieces of information we need and serve it back up. And neither of these things are really ideal, of course. We want to have the next generation architecture that replaces the old data systems and also provides the types of analytics that we need at scale. So to kind of go on, you know, I mentioned a few different challenges, but what's the core problem that we're really seeing, and what's the core problem that I really see in talking to our clients? Because, there we go. It's not really the unwillingness to expose data, and it's not the unwillingness to invest in the data lake, and it's certainly not a lack of awesome ideas from people about what to do with their data. It's most of the time that people just don't know what data they have. They don't know what data is available. They don't know when the stored procedure was written. They don't know when the database needs to be updated. And really, in order for us to be able to effectively harness this awesome big data lake and this big data platform, we really need to unlock the data and bring it together. But of course, we can't just open the fire hose, right? And that's what, when we go to clients and they want to bring in Twitter data, they want to bring in social media data, there's a long process behind that. We can't just let all of the information in. And it's my experience that the management and the processes around getting all of that set up and getting it governed is really one of the longest parts. It's not the technology, but it's actually making sure that we can do it in a secure way, in a way that makes business sense. So this was kind of the core challenge, is unlocking the information, helping clients understand what data they have, and trying to create a data governance framework that can intelligently try to figure some of the stuff out for us, so it's not so people-driven, but it's a bit more technology-driven. And so how are we actually going to do this? Because you know, it's not enough just to talk about it or just to build a PowerPoint. We wanted to actually build a strategy and then build an actual a live platform that addressed some of those challenges and then made it actionable. So how are we going to create a platform where we can bring in all sorts of different data sets but make sure that we're not passing around clear text credit card numbers? And these are just some high-level points, and I think I'll go into them a bit more in the following slides, but just kind of showing how we took this strategy and wanted to make it technically actionable, so how we wanted to put it onto the platform and make it real. So the first two pieces I'm just going to go into in a bit more detail are policies and metadata. And we kind of have a colloquial definition on the slides right there. And metadata is, of course, a piece of information about another piece of data. But really, to us, it's a piece of useful information. It's a tag, or it's something that describes the entity, that describes a trait of the data. And metadata is really something that can be utilized and generated all along our pipelines. All along our pipeline, we can generate new metadata by running rules or creating tags. And then we can consume that metadata and make it actionable. And we want to make it actionable through policies. And policies are just basically a rules engine, or a way to think about a set of rules that have a technical definition. So oftentimes a policy is actually at the handshake between business and technology. So if we have a policy that says that we can't hold both credit card numbers and the zip code in the same table, then there's obviously a technical manifestation of that. And there's a cycle between determining what type of data we have, tagging it and associating it with metadata, and then allowing that metadata to speak for itself and drive these policies. And there's a few different types of metadata that are on the slide here. Business metadata is the first one. And this is normally our people-heavy metadata. This is information that could be locked up in people's heads, or it's an understanding of how the business works. There's operational metadata, and this is all of our processes. So this could be our different metrics as we process information along the pipeline, or this could be the exact process and how we roll on our users. And then there's technical metadata itself. So this is all of the applications and all of the different tools that are running. They're all generating metadata as well. And this metadata is really, really useful. And we'd like to be able to centrally house it and then utilize it along in our pipeline to make some of these actionable decisions. And that's kind of the other half of the policy, which is the action. So if the policy says that I can't hold a credit card number in clear text, the output of that policy could be to encrypt it, or to tokenize it, or to mask it, or make some type of decision. So though it's just kind of a framework for executing our business logic in a technical way that drives this data governance and drives a lot of the technical requirements that we're going to have. So that was the first part, was focusing on metadata and how it could drive policies and policies as a business rule. And the next part was actually bringing in the AI and taking it to the next level. So as I mentioned, this is not the first iteration of this offering. This is actually the second, maybe 2.5. And in the first iteration of us talking about data governance, we built a big data platform, and we created a framework that was able to use regular expressions to read over our data as it was being ingested, determine that if it was a credit card number, determine if it was an IP address, and then tag that with a piece of metadata. So if it was, you could tag it as a billing information, or you could tag it as PII. And this was pretty cool because it allowed us to ingest information a bit faster, and it allowed us to tag it, and then we could make it actionable, by masking it or anything. But it was a bit limited. It was really limited to us understanding what the data was ahead of time, because these tags relied on us understanding that the credit card number was going to be in there, having written the regex scripts, or even worse, using the headers of the table file. So just only understanding the headers. So it was a little bit limiting in what we were able to do in our massive goal to categorize and unlock this data. And that's where we really wanted to bring in machine learning into the next iteration of this platform to sort of address this scalable governance. And we can see here, the graphic is just kind of showing that over time, we obviously want to do better and better machine learning. We want our model to get better. So initially, our algorithm might just be doing point anomaly detection, just saying that if a credit card number comes in and it's over 16 digits, then that is not very good. So that's just one point of information. And that's still pretty good, and that's what we were doing in our last iteration of this. But we actually want to use AI to make that method smarter. So over time, we could say, well, not only is the credit card number corrupt, but it also seems to be corrupt every time it comes from, the county of Dayton, Ohio. And then there's also like the longer version of that, which is, how can we determine if something is going to be corrupt and making that better. So what we're currently doing now is we have used some different machine learning kits to actually run in our ingestion scripts and go through all the information that's being ingested and try to determine what it is and do some really cool tagging and do this data categorization that's going to be required to scale out this solution and to unlock the information at scale. And this is just kind of showing a little bit of a solution cycle into what that machine learning process is. So we're going to sample a piece of the information. We're going to have to encode it from an alpha to a numeric value. And then the algorithm will actually work on this numeric value. And then we can eventually scale this and do more and more advanced anomaly detection. And this anomaly detection is really important for our data governance solution, of course, because we're trying to unlock the information. We're trying to have a compliant and well-managed platform at scale. So we're going to use this, again, in kind of our processing framework to try to determine when things are not looking correct or when we need to do some kind of action as defined in our policy. So what's kind of what's the conceptual architecture? So this is our conceptual architecture slide. And we can see along the bottom are the different data governance pillars that were defined a few slides earlier. And it's kind of just showing spatially where they align the platform along the different way. And we can see that we have our typical sources of data. We're missing a box there. We have our typical sources of data. We have our different ingestion applications. And then we actually want to load all of our information into our platform and then do something with it. And a core part of this framework that we've designed is that no matter where the information comes from, no matter what ingestion application it is, if it's a data profiling tool, or if it's Flume, or if it's Kafka, everything lands in the same place. Everything lands in the ingestion zone. And that's a hard requirement, because we have to be able to create some type of controls over this process to be able to run our data governance framework and run our AI and do all the categorization we need. So we can see that we have our landing zone here, and the top is showing some kind of ingestion zone, and the bottom is showing more of a queue visually. And we would see that we would run our little framework, and we'd run our machine learning against all this information, and then actually go and process it. Then we would write it to our different HDFS zones, and this is showing a reject zone, because you'd normally always have some flow where we're saying that a record doesn't look correct, so we're not going to write it. And then we would eventually have our consumption zone, which is our lockdown tables that our different users have access to. And beyond the framework being executed in the landing zone right there, you can also do different metadata and policy checks across the different zones. So in each one of these processing zones, you could be executing a similar algorithm to do beyond what you first wanted to do. So initially, we could just see if records were corrupt, and then we could see if records were formatted correctly, and then we could see how they compared to other records. And kind of each part of this pipeline, we could make it more and more intelligent. So by the time it got to the consumption zone, it was well managed, and we knew exactly what it was, and it was tokenized, and it was encrypted, as was defined in our policies, and was instantiated in these frameworks that we've sort of built into our processing. So this is kind of the conceptual architecture, and you can notice there's no vendors yet, because we wanted to look at conceptually the problem that we were trying to solve, and then we wanted to look at the different tools in the marketplace that could help us tackle that. So we did, as I mentioned, look at over 31 tools in the marketplace, and I think that's still going strong. And it's an effort that we try to keep going to stay relevant about what tools are coming into the marketplace and what's the most useful. And we looked at a lot of different ones at a high level, and then we focused on about 12 to 15 at a much lower level, and then actually installed them on our platform, looked at the different functionalities, plotted it against all of our different data governance pillars, and wanted to pick an end reference architecture that we were really happy with. And these are just some of the logos of a lot of some of the products that we looked at and some of the really awesome tools that we've actually integrated right now. And there were a few key things that we wanted to look at in evaluating the tools. Beyond if it fits the data governance use case, we wanted to look at specifically data governance related to big data. So does it play native with Hadoop? Can it run Spark jobs? Or is it just doing like a REST API call? We wanted things that were pretty native. We also wanted things that were kind of metadata driven as well. So we wanted things that could export and import metadata, because we really wanted to use this metadata and policy framework all along the platform. So we wanted to be able to export and import that information as necessary. And really, I think also just things that had really awesome features that we hadn't seen before, things that alleviated a lot of the operational processes, like things that took people out of the equation, that allowed us to automate this as much as possible. That was really the focus, was automation and then native Hadoop connectivity and driving this governance solution. So this is the actual architecture, and this is something that I mentioned is live now. We've built the demo, and it's running on an Amazon cluster, and it's currently running Hortonworks as our base platform, and then Spark is the processing engine. I don't think we'll have time in this talk to do a demo, but we're happy to stay after and kind of show some of the finer pieces. But this is again, kind of the reference architecture, and then we can see that we did select a handful of tools to sort of meet this end-to-end governance flow. So the first tool we looked at was we wanted to use something for data profiling. So it would be all great if our machine learning algorithm was smart enough tomorrow to be able to tell us if there was a credit card number. But unfortunately, it's not. It's going to take a little bit of time. We're going to have to tune it. So we wanted to bring in a third-party tool or some kind of data profiling tool to sort of like allow us to get beyond that initial phase. We wanted to be able to look at some data and do some of our data governance, determine what it was, as our machine learning algorithm is getting smarter. So we have Paxata deployed, and we can kind of use that to do some data sampling and to do some of our initial processing. And Paxata is also good because it will write to our HDFS and utilize Spark. But again, kind of along what we mentioned before, that's always going to write to our little ingestion zone. So even though Paxata has a direct hook to HDFS, it's still going to write to our landing zone that we're going to execute our little data governance framework across it every time. The next piece was NiFi, which again comes with Hortonworks, kind of part of the stack. And we use this to do all of our data processing. So as we want to run our little data governance framework, we utilize NiFi to actually execute that. And our little data governance framework contains a lot of different policies and actions that allow us to manage the information. So first in our data governance framework is our actual AI algorithm. So the machine learning algorithm that's going to run and try to tell us over time more intelligently what's in the information. And then we've also built in our regular regex and our regular tagging scripts that are going to read in the information and pick out basic things like credit card numbers, IP addresses, information that we already understand. And then it's also going to do basic things like look at how big the file is and whether or not it's of the right format. And then it can actually take action. So it can decide to go write it to the raw zone, or it can decide to write it to the exception zone. So NiFi is being used as the processor to actually execute that data governance framework every time something goes on the landing zone. So as it goes along the pipeline, it's already been tagged and encrypted and masked and everything that we want it to do, because we were able to do that kind of intelligent ingestion on the front. And for our machine learning part, we are using Google's scikit-learn, and this is an SVM machine learning algorithm. And again, it's going to allow us to do a lot more categorization, long-term anomaly mapping, look at long-term patterns. And SVM is also good because it will start working on a smaller data set. So you don't need to have an enormous data set. It will start working right away. And in developing up our SVM, we're doing it in really two places. We're going to run our SVM over our large set of data that's stored in the data lake, and we can do this offline or whenever people aren't using it. This is going to allow us to make our model a lot better, and then we'll execute that model as we are ingesting the information. So we're going to train our model to get better, and then again, we'll use it as information is loaded onto the landing zone so we can intelligently try to classify it and tag it and know what it is. The third part of it was Apache Atlas. So in that we were focused on metadata, and we were focused on policies and tagging, we really needed to have a good metadata repository, and some of the new features of Atlas fit right in well with that and really matched our use case. So we're utilizing Apache Atlas for our repository, for doing some of our lineage, for keeping track of our tags. And Atlas has a really great UI that allows us to actually search for our different metadata tags and search for all these attributes that we've created, and then pull up all the different relevant information. So good end-to-end kind of lineage and tagging that's kind of covering that part of the solution. And then the last application we use is actually this really cool engine called Blue Talon. And what Blue Talon does is it does a lot of really intelligent security and user access mapping. Normally, user access mapping is done by an admin logging on and creating a user and assigning that user to a group and then assigning that group to a particular set of data. And it's normally a highly scripted process. It's a very manual process. And we found that Blue Talon is actually very good at automating that process, and it also has a really good graphical user interface. So it allows us to kind of do some of that user management better. And another thing that we kind of did as part of this iteration of using Blue Talon was actually utilizing their API functionality to dynamically write user policies. So within our data zone, as we go along our processing zone, suppose we ingest a piece of information and we don't think it's corrupt, so we want to store it on our platform, but we're not really sure what it is, so we want to really restrict access to it. Well, in the traditional user access management model, this would be very difficult because you would have to associate a user to a folder or a user to a piece of data. But if we don't know what the data is, we can't really make that assignment. So what we've done in our processing is we've created our little, what I call our WTF zone, which is basically an exception flow zone. And anytime a piece of information gets loaded into this zone, it calls the Blue Talon API, which dynamically creates a new user access policy for it on the spot, and then assigns it to a very specific, highly secured user right there and then. So we're able to ingest it and hold it down, and then dynamically call that API to do the user management, which is a bit cooler than if you had to do it the old way where you would have to understand that data ahead of time. So this is kind of the end-to-end flow we have right now, kind of showing some of the main components here. And really, again, the idea is to use our data lake and then do some kind of smart ingestion and really utilizing artificial intelligence and machine learning to drive a lot of this data governance framework ingestion. So we can ingest just large amounts of information and be a lot less worried about whether or not we're going to accidentally put someone's credit card on our database. So it's kind of a way for us to do that at much larger scale and do that much more efficiently. And we do have this live right now. The current use case we have deployed onto it is related to the project that I mentioned around European telco use cases. So a lot of the tagging is around what country the information came from and assigning PII data and looking at probe data. But we're also looking into doing something with healthcare information in the future. We've got a lot of interest in that. I think that this is, that could be an outlet for this. But yes, it was really about building something on big data that was end-to-end data governance driven and utilized a lot of the applications and allowed us to ingest this information at scale and unlock the data that we really see as the core problem for our clients. And kind of just don't really have the demo up right now for time, but this is just kind of showing one of the shots. This is actually our NiFi flow where we're doing, we can see here in the box, we're actually running our little smart ingestion framework here, we're running our machine learning. And as we process our data from the landing zone, we can see that we're moving it in between zones and we're taking action on it. So we're running our machine learning algorithm. We've decided that we could detect PII data. Then we've taken the move to mask the PII data and assign the tags and kind of go through this flow. So this is showing our sort of core data governance flow that's happening every time a piece of information is loaded onto this landing zone before it goes to the end consumer. And then this is just showing our Atlas UI that is looking at the different tags. And again, these tags are happening as a result of data being processed along the pipeline and executing against our data framework, and then us understanding that this could be a piece of sensitive information or however else we want to tag it. And we can see here we've tagged it as PII as one of the tags and then corrupt as the other. And so, yeah, the framework runs to generate these tags, and then the tags are picked up by Apache Atlas, and we can very easily look for what kind of tags and what kind of sensitive information has been recently processed. So yeah, that's kind of it. I'm about out of time. I think we started a couple minutes late. So I'm happy to take some questions. And again, this is something that we've built live and we could have ready to show to kind of talk about, yeah, utilizing AI to drive some data governance. Yes?
So Blue Talon, where you're doing user management, is that something that Apache Ranger can do, but you're choosing Blue Talon? Or is there an overlap?
Yeah, there's definitely an overlap. It's a similar tool. Blue Talon has a lot, I think, much better GUI features, and it allows us to kind of slice between policy and user a lot faster, but there is some overlap. I think in Ranger you'd have to do a bit more scripting. And that was kind of our experience in working with Sentry as well. That Sentry has those permissions, but you have to kind of create that nested Sentry view to get the same type of policy slice that we're able to do graphically here. Yeah. Yeah. No, go ahead, yeah. For Paxata? Yeah, so I think we looked at a few. I think Paxata does a good job of it's very visual where you can quickly see the profile. It also, again, it now has a direct Spark hook, so it'll write to HDFS better. But the reasoning was to kind of, as opposed to other tools, we like the functions, and then the reasoning for using it was, again, to kind of do that initial data profiling, data ingestion before we tried to run our machine learning batch algorithm. But yeah, I think the features work very well.
Question. Sorry, I've got the mic here, so I'll override. Loudest voice, I guess. Two quick questions, actually. First of all, since you saw how many people were taking pictures of your slides, will the presentation be available?
Yes, yeah, definitely.
Okay, and then the second question is, when you're doing the metadata tagging, are you generally doing it at the record level, or are you getting down to the field level, or at what level of granularity are you applying those tags as you're doing this iteration of your system?
Right. Well, it could be at a few different levels. We would want to do the tagging based on the actual data element. So we'd want to do the tagging based on the elements within the record. But then we could tag the record. And over time, we could actually tag the entire file itself. So that we can adjust that. Right now, I think we do it. One of our tags happens at a file level, but it's within the record. Within the record, you'd want to pick up the attribute and then tag that. But you could definitely do it either way. If you wanted to tag, maybe you wanted to mark the entire file as corrupt, or you could just tag that record. In our instance, we wanted to kind of not just look at records, but almost look at an entire blob of data. So if you just had a ton of web logs and they weren't separated by the normal double colon and they just came across as one thing, in that point we would want to just tag our entire blob because they wouldn't be at a record level. So we would just detect there was one thing and then we would tag the entire file. But I think it kind of depends on what information you're bringing in and how well you know it's structured. If it's at a record level, you can definitely tag at that level. Yes?
You mentioned a couple of times that the data is corrupt. What do you mean by that?
I think it's just an example if a piece of information could be corrupt. So for our example, if we are trying to do financial information, we might, we don't want to hold a record where the credit card number is 17 versus 16 digits, or where we were looking at IP addresses, if the IP address is from a blacklisted IP, or if it's 123.0.0.0 where we know it's not correct, the IP. So it's more about, the corrupt is a colloquial term. That's how we're defining that something is corrupt. So we would use a policy to say that anything where a credit card number isn't 16 digits is corrupt, and then every time we read a credit card number that wasn't 16 digits, it would get tagged as corrupt. But it's more of a linguistics. You could call it bad or error or whatever you wanted to call it. That's just what we call the tags. So when we run our script, we've called that corrupt, but it's more of a term.
Yeah.
Yeah. Well,
Oh, no, so those tools that you're showing that they do actually integrate with Atlas and Ranger, right?
yes, exactly. This is all meant to be on the main platform. Yeah.
Very good, thank you. I like this. It sounds like that the Atlas and the Blue Talon is a two-way communication. That there are times where Atlas is pushing to Blue Talon and say, "Hey, I got something bad here. You need to do something about it," and then also that Blue Talon is reaching back into Atlas to get its metadata objects and create policies based on that. Is it really a two-way between the two? Do you know?
Yeah, well, we don't have it set up as much as that right now. We have our policies based on our actual data governance execution framework. So our wrapper actually is what calls the Blue Talon API, and our wrapper is what pushes.
So your wrapper sits in the middle and talks to both of those entities.
Yes, yeah. It sits before that, but we have some great gentlemen sitting here from Blue Talon that could definitely give you some details about the expansion of their metadata, but we haven't exactly utilized it like that. Although you could, there is an API to be able to share that information. The way we call it and the way we execute the user access policies is based on the data and the way we've tagged it. But I do think there's integration to do that. Yes.
The data actually move to staging zone, and then the cleansing is happening there. Then it further moves into the processing zone. Is that the way it's architected?
Yes, I think it has to initially load. It has to load in some place where we can execute our NiFi process to run that checklist.
The data at rest at the staging zone is unprotected, or like it's like the policy is going to be applied on that. That's still there in the HDFS system.
I'm sorry, what?
The data is available in the HDFS system unprotected, again in the staging zone. For temporary.
Unprotected?
He's saying ingestion zone is unprotected, not it is protected. It is protected.
Well, yeah, I'm not. It is. I mean, how is it? How is it?
His question was, is the ingestion zone protected?
After
Yeah.
ingesting the data
Right.
in the temporary zone or staging zone, it is open to all, no? Like what is the strategy there? Like it's a
Oh no, only like a functional user has access to that account. I mean, it wouldn't be open to all, and it would only happen. So the moment it lands, the NiFi process runs. Because
NiFi is
NiFi
so
runs
run on that one,
continuously.
okay.
So the moment it lands into the zone, and the moment it lands into our queue, that process happens instantly in a secured container.
and what is the retention policy on that one? It gets discarded like after moving to the processing zone, or it's still going to be there? There is going to be rest there.
Yeah, so there's an exception flow. So if it was corrupt or insecure, it would be deleted, and it would get deleted. And then if it was correct, it would go to the HDF landing zone. But that process is running continuously. So the moment it crosses, that process runs to run that check.
Okay, all right. Thank you.
Yeah. Okay. Okay.
Hi, quick question. On the overall process, how do you engage business users to help you define the business taxonomy or business to the data dictionary?
Yeah. So we didn't show that in this demo, but we actually also have Calibra installed, and we've looked at a few different tools to do exactly just that. In the previous version of this, we showed a Calibra template, and I think that what that does a good job is you can actually define metadata templates. So as a business owner, as a business user, you can create a template for what information is required to ingest or what information is required to be captured. We didn't integrate that with our framework because we didn't really find a great way to export that metadata template into our workflow. It's something that we've been kind of talking with them about, but that was kind of one of the main tools we looked at was for keeping track of the business glossary. And that also did a good job of actually defining users beyond just a regular user. There were like data owners and there were data stewards, and each one of those people had a different type of permission. They had even the screen looked different for them. So we thought that was kind of useful in further breaking down what people's actual roles were and giving that permission. But we didn't show that here because this was kind of more focused on the processing framework. Cool. All right. Well, we'll be here if anyone has any other questions.